Hey everyone, we're going to start a new chapter, which is all about how to name chemicals and write their formulas. We're going to break it down into the different types of compounds that we've learned. First, we're going to talk about and review naming ions. A lot of today's section is going to be review, but we have to understand how to name ions in order to move on to section 2, which is naming ionic compounds. From there, we're going to move on to naming and writing for molecular compounds, and then we're going to end on naming and writing formulas for acids and bases. This chapter starts off with a picture of these bottles, and it says, "Do you speak chemistry?" If you were to look at the ingredient labels of household products around your house, whether that be a bottle of shampoo, a tube of toothpaste, or even a box of detergent, you're going to see names of ingredients on the side. Oftentimes, these don't make sense because most people don't read or understand or speak chemistry. Our goals of this chapter is to actually help you understand and be able to make sense of those products' names in terms of simple compounds. The goal of today's lesson is we're going to focus on monoatomic ions. And therefore, we're going to learn how to determine the charge and name for many monoatomic ions. As we've already stated, it's important in order to learn the language of chemistry to be able to write names and the formulas for ionic compounds. But we can't just jump right into ionic compounds. We first have to break it down into the steps of learning about ions first. This is why we're reviewing a lot of the information that we learned when we were going over what are ionic compounds. Again, today we're going to focus on monoatomic ions. Mono meaning one, atomic meaning atom. This is one single atom, and it's going to have a positive or a negative charge, hence why the word ion follows it. Remember, atoms tend to become positive or negative because they have lost or gained one or more of their valence electrons. When we were talking about atoms in the past chapters, we've talked about two types. The first thing we've talked about are cations, and then we talked about anions. Those are two things that we're going to review today. Let's start off with cations. Recall that these are going to be mostly metallic elements. So when I say metallic, I'm talking about your metals. And these are generally going to be on the left side of your periodic table. These are formed because these metals have lost their valence electrons, and since electrons are negatively charged, they've lost a negative charge. Therefore, they become more positive. So overall, since they've lost that negative charge, they get a positive for their sign. Remember, in the past, I've always said that cats kind of make me happy, which is why they get that positive sign. If you recall, elements in group 1A tend to become cations because they are going to lose the one valence electron they have rather than try to get 7 more to get to the full octet. So group 1A gets a 1 plus charge. These are things like lithium, sodium, potassium, rubidium, and cesium. Group 2A metals tend to lose the 2 valence electrons they have, then try to get 6 more. So things like calcium and magnesium tend to get a 2 plus charge. Aluminum, which is common in group 3A metal, these are going to lose 3 electrons and therefore get a 3 plus charge. So our general rule, if I had to encompass all of that into one single sentence, says when metals in groups 1, 2, or 3 lose electrons, they form cations with a positive charge equal to their group number. So remember, if they were in group 1, the positive charge is plus 1. If they're in group 2, the positive charge is plus 2. If they are in 3, their positive charge is plus 3. On the other end of that, we have to learn about naming because I said we talk about charges and names. Well, cations in group 1, 2, and 3, their name is the same as their original name of the metal. All we did was put the word ion or the word cation behind it. If we look at this example of sodium, it stays sodium, nothing changed about it. All we did was put the word ion after it. And notice there's a space here because these are two separate words. Calcium becomes calcium ion. And then aluminum becomes aluminum ion. On the other end of the spectrum, we're going to talk about anions. These are mostly nonmetals. Remember, nonmetals are going to be on the right side of the periodic table. They tend to gain electrons because their octets are relatively full. They tend to have 5, 6, and 7 valence electrons, so it doesn't take much in order to get to 8. These tend to have a negative charge, so when you hear the word anion, I always think of like anti, or someone told me in class, like onions, they make you cry, they're negative. They get that negative charge. To answer our key question, or what we hope to learn from this section, let's first determine how to find the charge, and then let's talk about their names. So the charge of any anion in group A is going to be determined by taking the group number minus 8, or in other words, subtracting 8 from the group number. We're going to go through several examples down below. And then while we're doing that, we're also going to go through examples of naming. So an anion starts with the stem of the element's name and generally ends in "ide." So if you ever see a negative charge, that ion should always end in IDE. So let's first focus on group 7A. Well, group 7A, if we're focusing on the charge, the group number is 7 minus 8. That means my charge would be a negative 1. Also recall that the anions always end in "ide." So since I have a negative 1 charge, chlorine and fluorine, the endings get cut off both of those, and they become fluoride and chloride respectively. If we were going to look at group 6A, well, if I was going to focus on the charge, 6 minus 8 means my charge is a negative 2. I have a negative charge. My ending has to end in "ide." So oxygen and sulfur, which are normal elements in group 6, are going to become oxide and sulfide. And the last one, groups 5A, if we're going to focus on the charge, 5 minus 8 gives me a negative 3 charge. Since I have this negative charge, I have to end in "ide." Elements like nitrogen, phosphorus, and arsenic would become nitride, phosphide, and arsenide. I noticed that when we were doing these in the past, a lot of you guys struggled on where to cut off the elements. So if you look on your guys' notes that I hand out in class, there's a little table that shows you what are the stem words and where do you end "ide" on for the most common anions that you're going to find. Most of that you just learned was review. What we're going to talk about now is something new. Please note that these are going to be metals that form more than one ion. In the past, we've skipped talking about transition metals. Remember, these are group B elements, and these are located in the middle of your periodic table. So if you were looking on your periodic table, they go from here all the way over to here. And we've highlighted a lot of these that are going to form more than one ion. Specifically, I want to point out that they are going to form cations, so they're always going to have a positive charge. I've listed these elements in your notes. They are bolded, located at the top of the page, and they are chromium, manganese, iron, cobalt, copper, and mercury. I've also listed 2 more, tin and lead. Tin and lead are in group 4, but they're included in this list because they can actually have more than one ionic charge. They can have a 2+ charge or a 4+. There are two more that I would like you to add to your guided notes, and those are gold, which is AU for the symbol, and the other one is nickel, which is NI. I want you to add that to your list. Now, since these have more than one possible charge, the charge of these have to be determined by saying how many electrons are being lost. For example, if you get an iron and I say, give me the charge of iron, you could give me a 2+ or a 3+. And you wouldn't know which one's the correct answer unless I told you how many they lost. So I'd have to tell you they lost 2 or they've lost 3 electrons. Now, on your homework, I'm not going to say iron lost 2 electrons. We're going to be using something known as the stock system to tell you how many electrons it lost. So what is the stock system? The stock system uses Roman numerals. If you don't know what Roman numerals are, I've posted a picture in your notes and they're located down here, 1 through 10. And you won't ever need anything bigger than a 7. The Roman numerals indicates the charge. So if I have a Roman numeral 1, my charge is going to be a +1. If I have Roman numeral 2, the charge is going to be a +2. Roman numeral 3, the charge is a +3. And notice this charge is always positive because we're working with metals. Here's a specific example. If I say you have Fe2+, you should be able to tell me that's iron 2 ion. If I gave you the name iron 2 ion, you should be able to tell me vice versa, it has a 2+ charge. You will always be given the charge or the Roman numeral, so you can be able to tell what the other one is. Note, everything that I listed on this slide, all those elements at the top of the paper, will have a Roman numeral. If they don't have a Roman numeral with their name, it is wrong. For example, if I say manganese, you should be able to tell me that the charge is a +4 because of this Roman numeral. Vice versa, if I give you something like, you should be able to tell me that the charge, I should write that out, lead, is a 2+. If I look at other examples, if I give you, let's say, you should be able to look at your periodic table and see that tin, Sn is tin. The Roman numeral will be 4 because you're given the number, followed by ion. If I gave you, you should be able to look at your periodic table, say that this is copper. It's on my list, so it becomes a 1 ion. Now, there are a few transition metals that have only one charge. They are not on your list. Therefore, they do not get a Roman numeral. And these charges are ones that you're going to have to memorize. And when I say memorize, just understand where you're going to find them. These charges are actually found in the top right-hand corner of the box of the element. If you get out your periodic table and find silver on your periodic table, you're going to see a +1 in the corner because silver is always a +1. Cadmium and zinc are always going to be a +2. And you can find that again on the periodic table in the top right-hand corner. And that's the end of today's lesson. If you have any questions, make sure you reach out and ask. Otherwise, I hope you guys have a great day.